engineer working for a company that makes insulated coffee mugs. You got 10,000 of them sitting in the warehouse next door that should be shipping to customers any day now, but when you pull your stock to quality check them, they do that. You've checked these things with every tool at your disposal. Bore gauges, micrometers, calipers, or even durometer tested the rubber of the gasket. Everything is within spec, but still, they do that. So keep watching to learn how you can use digital assembly to inspect what no other hand tool can show you.
Nice.
This mug is particularly frustrating because not all orientations of the lid on the mug itself causes a leaking condition. So I can't just scan these two parts separately and align them in the GOM Inspect software because I need to understand why this relationship is causing a leak and other relationships don't. To do this, I've placed reference points on the lid and the mug, minimum of 3 of each, but I have more to aid in scanning, and I'm going to capture the relationship of these actual objects using a process called photogrammetry. Photogrammetry allows us to capture the precise 3D coordinates of reference points using a digital camera. By collecting the reference points on these parts, after we scan them, we'll be able to transform their digital twin into the exact configuration that we know has an issue. I've finished the photogrammetry and I've saved the project as mugempty.ginspect. I'm also going to resave the project, so that's File, Save As, and this will just be mug.ginspect. Once that's done, I can disassemble my mug and lid and scan my mug with the HOSQ sensor. All right, we finished scanning our mug, as we can see here, and we even finished polygonizing it. Now, the key step here in making digital assembly work correctly is this right here. Scan 1 depends on photogrammetry 1. Now, you can do this when you create the measurement series. When you're in your digitized workspace and you hit your Add New, you can add a dependent ATOS measurement series. You can also right-click, edit creation parameters, and select that it is a dependent measurement series and force it to be linked to photogrammetry 1. And the reason this is important is this means if we have all of our meshes transformed into photogrammetry 1, all of our meshes of all of our pieces will be in the exact same orientation to each other they were when we shot photogrammetry. It allows us to inspect these as assembled, which is something you're not going to be able to do with a lot of other systems and techniques. So now that we've got that crucial step taken care of, the last couple of steps here is really just cleaning this up. I've got more data here than I frankly need to troubleshoot what I need to troubleshoot. So the seal is compressed on this chamfer right here, and it actually seals with the mug in this region right here. Everything below that doesn't really matter, and in my subsequent calculations, it may end up slowing me down just a little bit. So what I'm going to do is delete that data, and to do that, I'm going to use my Select Deselect Through Surface tool. I'm just going to select the region below there that I don't care about, and with that selected, I can Control Delete to get rid of it. I also picked up some reference points on the outside of the mug that I don't need as well. So what I'm going to do is use my Select Patch tool. I'm going to select the area that is the inside surface of my mug and hit Escape to tell the software that I'm done selecting patches. Once that's done, I can hit Control-I to invert my selection, and then Control-Delete to delete that as well. With all of that completed, the last step is to export this. So I'm going to select it in my Explorer, go to File, Export Mesh, G3D. This is the format I prefer. You can use an STL, but the G3D format is used by GOM, and this is actually how it handles all of its data internally. So it's very fast to export, very fast to import. The last step is just making sure you select a destination folder. So in this case, my mug project folder, and we'll just call this mug.g3d. Go ahead and save, okay. And with that, we can move on to scanning our lid. All right, I finished scanning the mug, so I can set that guy aside. And I'm gonna open that first project, that mug empty.ginspect. I'm gonna save it again, file save as lid.ginspect. And the next step is to prep my lid for scanning. Now, one of the problems with any optical-based measurement system is that translucent or transparent objects simply can't scan by themselves. This is a limitation that's unfortunately just one of those annoying laws of physics. So to get around that, we have to coat this with something that we are able to spray. And one of the products we use quite a bit here is A-Sub. A-Sub is an evaporating spray. What that means is that you apply it on and it turns matte white, and then anywhere from 3 to 4 hours later, it sublimates off your part, leaving no residue behind. It's a fantastic tool and a very easy way to make your parts scannable without a hassle of all the cleanup. All right, so we finished scanning our mug, and just like before, we have this key here, depends on photogrammetry 1. That is done, right? Our measurement series depends on photogrammetry 1, so it's in the exact same coordinate system as our mug itself. We don't really have any excess data to get rid of on here, so we're just gonna keep everything. So once again, I'm just gonna select my mesh, File, Export, Mesh, G3D, and in this case, I'm going to select the same location, and we'll just name this lid.g3d. And go ahead and hit OK. And now we can open a brand new project. All right, so I have a brand new project open. We'll go ahead and save it right now, and we'll call this mug assembly, mugassembly.ginspect. We'll go ahead and hit OK there. Now we need to bring in both our mug and the lid. So we'll go to that location and bring in our lid, new part, and we'll go ahead and name that part lid just to make it easy to keep track of, and we'll bring in the mug, new part, and we'll call that mug. And you can see here that they are transformed into the exact same coordinate system. You see that? It might be a little bit hard to see. Let's cut a section view so you can take a look and see how that works. So now that we've cut that section view, you can see here how it makes contact. The inner wall of our mug is here, and the outer area of our lid is here, and you can see this is the part of the seal that ends up being compressed that actually allows it to seal. So we know we have to have some kind of defect in the seal somewhere around here to be causing a leak like that, or possibly a defect in the mug, likely a combination of the two. To make it easy to see what's going on, I'm going to make my mug invisible. And the first thing I want to do is I want this to be in a nice coordinate system. We can see if I try to straighten this out to a nice coordinate system, it ends up being in a weird orientation. So I'm going to make my mug exclusively visible, and I'm going to create an alignment for this. And this is going to be a 3-2-1 alignment since I don't have CAD. I'm going to select 3 points on the top of the mug that are going to make up my Z plane. I'm going to select 2 other points that'll just give me a Y direction, and 1 more point on the inside that'll give me an X direction. I'll go ahead and hit OK. And so now I've got my mug conveniently lined up to a coordinate system, so that looks nice. When I rotate around, I get an orientation that makes a lot of sense. However, when I bring my lid back and make it visible, we can see that it's not oriented at all correctly anymore. To fix this issue, we need to add an alignment to our lid as well. And the alignment I'm going to add is a special alignment. I'm going to go to Operations, Alignment, Initial Alignment, and the alignment I'm going to use is called Copy Alignment as Initial Alignment. What this is going to do is it's going to copy the exact same translations and rotations that were applied to my first part, and it's going to apply them to this second part. So that's what this function does. It allows you to copy an alignment for another part. And now they're in the same coordinate system, but also conveniently lined up to our global coordinate system, making inspections a little bit easier. One of the coolest inspections we can do in the software for digital assembly is called a surface distance comparison. So I'm going to do one of those now. I'm going to select the area of the lid that includes the seal using our Select Deselect Through Surface tool. And I'm going to go to Construct, Distance, Surface Distance. And I'm going to tell it that I want to measure the distance between here and our mug. Go ahead and hit OK. What you're seeing here is a color map where the colors represent the distance between the lid and the mug's surface. With this scale though, it's a little bit harder to see what's going on. So I'm gonna make this minus 30 thou. I'm gonna make this plus 60 thou. This is mostly just guessing. And I'm going to right click and show histogram so we can see we've got sort of two peaks in our histogram. We've got one here that corresponds to the bulk of the material, the middle of this seal here and the areas on either side that have actually quite some distance between themselves and the mug itself. But then we also have this area right here in this sort of minus 15 thousandths, which indicates this is the area where the seal is actually making contact with the mug. We can see that in here, but we can also see we have a little bit of a low spot right there and a little one right there. To get a feeling of how low that low spot is, we can add deviation labels to this. To do that, I'm going to control right click to open the eye inspect wheel, and I'm going to select deviation label. And then I can just control click on the mesh to add a deviation label. We can see that this is significantly less than the areas here. Less enough that maybe under compression, this gets pushed back just a little bit to allow water to pass through. If we bring in the mesh for our mug, we can also see that it turns out that when one of those is lined up perfectly with a dent in the mug, we actually see we've got 3 sets of 2 dimples in the mug, almost 120 degrees opposed from each other. That makes me think that at some point in the manufacturing process, something's grabbing the inside of this mug and kind of pulling outwards, maybe during the painting process, maybe during the rolling process, maybe it's just part of like moving this to a next process step. And it's possible that whatever's grabbing this mug is exerting just a little bit too much force on it and causing it to be dented. It turns out when we line one of those up with a tiny little imperfection in our seal, we could end up with an area that leaks. And that would explain why in some configurations, this seals just fine. This might not be enough to matter if the mug wasn't dented and it wasn't lined up with one of those dents. So digital assembly is an extremely powerful tool for helping to troubleshoot situations like this. You can configure your part in a known non-conforming state, as an example, and then understand what relationships between the parts could potentially be causing that state. We finished the analysis of the mug and lid, and we've noticed 2 issues. For the mug, we found 3 dents 120 degrees apart, indicating that some sort of 3-jaw clamp had grabbed it during the manufacturing process and dented it. The seal is a little less obvious. There's obviously damage to it, but without a full root cause investigation, it's difficult to say exactly how it was damaged. While there is much more to investigate, the digital assembly process allows you to discover at least the proximate cause and give you a jumping off point for your investigations. I hope you found this video useful. I've left a flowchart for digital assembly process in the video description if you have a tri-top end ATOS system and you'd like to do this yourself. If you have any questions about this process or feel that it could help you solve some of your manufacturing needs, please reach out to us at info@capture3d.com or visit our website. Thank you so much for watching, and we'll see you again soon. Who gave me one of the leaking ones? Steve, was it you? I'm gonna get you back, man.